G'day team, welcome back to another video, and again we are working with vectors. So today we're actually introducing a bit of a new idea, and it's the magnitude of a vector. Now magnitude also has another name, it's the length of the vector, alright? I want you guys to start getting in the habit of calling it the magnitude though, alright? You know, vector, the definition of vector is magnitude and direction, okay? Let's get in the habit of using the correct terminology. So if we've got a vector v, which is in component form 4, 2, and in unit vector form 4i plus 2j, all right, 4i, 2j, 4i plus 2j. Easy as geometrically adding them together is something we are all over. So the magnitude or length of vector v is given by modulus v, okay? So mod v, that is how that is read. So using Pythagoras, I know, bringing back Pythagoras, who would have thought working with vectors, we could incorporate Pythagoras, but here we are. So we're looking at our hypotenuse, which is vector v squared, so mod v squared. So the length of that is equal to 4 squared, so a squared plus b squared, so 4 squared plus 2 squared, which is 16 plus 4, which equals 20. So that means mod v, so the modulus of v, or the magnitude of vector v, is equal to the square root of 20 units. Now, usually we've been getting in the habit of writing plus or minus when we take the square root of both sides, but because we're dealing with magnitude and length, it will have to be positive, okay? So we reject that negative value. All right, so general formula for you guys. If vector v is equal to v1 and v2 in component form, which is equal to v1 times by unit vector I plus v2 times unit vector j, then the magnitude or length of vector v is mod v is equal to the square root of v1 squared plus v2 squared. It's as simple as that. All right. So make sure you have that formula down because we are actually going to be using it in these questions. So just quickly before we jump into questions, we're going to have a look at unit vectors as well. So unit vectors are vectors of length 1, i.e. the magnitude of the vector equals 1. So for an example, we've got the vector -1, 0. So we've gone left 1 unit, but we haven't gone up or down any units, all right? Mod v, using our formula above, v1 squared plus v2 squared, taking the square root, we've got -1 squared, which is 1, plus 0 squared, which is still 1. The square root of 1 is in fact 1. Therefore, and I actually am missing unit, all right? Therefore, vector v is a unit vector because it has magnitude 1. So a type of question you'll get is finding k given 3/5 and k is a unit vector. All right, so that means we are told that our magnitude is 1, and that is equal to the square root of v1, so 3 on 5 squared, plus k squared. Okay, this is how we find an unknown in our vector. All we're going to do now is solve for k. So getting rid of that square root, we're going to take the square of both sides. So 1 times 1 is 1, and that is equal to 3/5 squared plus k squared, okay? I'm going to write k squared on this side, 1 minus 3/5 squared, okay? So k squared equals 1 take 9 on 25, so that's going to be 16 on 25, all right? Take the square root of both sides, k is equal to plus or minus 4 on 5. So the square root of 16 is 4, square root of 25 is 5. Now, just before I said we are ignoring the negative values, but that was for the magnitude, okay? We are now looking at an unknown component inside a vector, which can be positive or negative. So we leave it as positive or negative, all right? So with that, I want you guys to have a crack at questions in 3D 1 through 5. All right. Hopefully this helps. Hopefully that's a really good example to get you guys going, and we'll see you guys